All right, so 6.3 is called trig functions of any angle. So instead of just being like the 30, 60, 90, those, you're going to learn how to also find the trig functions, and these are mostly in radians, but they can also be in degrees. These are mostly in radians. Instead of converting back and forth from radians to degrees and then find it using your triangles, you're going to learn how to utilize what's called the unit circle. So this on the left is your unit circle, okay? It is called a unit circle because it is a circle with a radius of 1. So we already know the quadrant stuff, right? We already knew that this was 0 degrees and that the coordinate point here is 1, 0. We already knew that this was 90 degrees or pi over 2 and that the coordinate point there at the top is 0, 1. We already knew this is 180 or pi and the coordinate there is negative 1, 0. And we already knew this was 3 pi over 2 or 270 and the coordinate there is 0, negative 1. Then we will double all the way back around, so you'll see when you see the blank one, we'll end back at 360 degrees, which is 2 pi. Same coordinate point, 1, 0, okay? So this is one full circle with a radius of 1. Now what's new is all the angles in between. There are 3 special angles in between each of the x-axis and the y-axis coordinate points. They are over 6s, over 4s, and over 3s, or 30, 60, 90 reference angles, which means that the values here repeat in each quadrant, okay? There's a pattern to those. The only thing that changes is your signs because all students take calculus, changes the signs, right? If we move left, whatever's using the x is going to get changed to negative. If we go down, whatever's using the y is going to change to negative. So you are going to fill out everything on this. And then once you know it, you can use our tricks of sine being y, cosine being x, tangent being y over x, and then the reciprocal functions on the other side. If I flip sine, I get cosecant. If I flip cosine, I get secant. And if I flip tangent, I get, oh, this should be cotangent. Ooh, that's cotangent. So now let's just say I said find the cosine at 45 degrees, which I will give in terms of radians, which would be pi over 4. Instead of drawing out a right triangle that is 45, 45, 1, 1, root 2, and finding adjacent over opposite, which would be 1 over root 2, which gets rationalized to root 2 over 2. Instead of doing that work, I could use my unit circle. I could locate my 45 degrees, which is here, or my pi over 4. And then I could look at the coordinate point there, which is root 2 over 2 and root 2 over 2, and I can pick the x, and that's the cosine. So you don't have to use a triangle to do that.
So we'll use this as a reference on a test this time.
Yep. So if I said find the sine at 330 degrees or 11 pi over 6, I would go to 11 pi over 6, and I would grab what? The x or the y? The y, which would be negative 1/2. If it wanted tangent, it's y over x. I'm going to teach you a trick to even learn the tangents, though, okay? But you could do y over x every time to get the tangent. Yep.
How do you know it's 11 pi over 6?
So it will, the questions in this section will now start to ask you in terms of radians, so that would be the given part.
So how would you know? You have to convert it back to degrees?
No, it will say find the sine of 11 pi over 6.
So you just have to memorize it?
You mean the points on the circle? Yeah, I'm going to teach you how to fill it in. Yep. Okay, so here's your blank one. So again, this is literally what your quiz is going to look like next week, except obviously it will be a place for your name at the top. That's the only difference, okay? So the way, I'll start with the degrees since it's the thing we've been working with the most, right? And start with the degrees that you're the most comfortable with. So on the right, notice the ones that have the dash with the little degree symbol. That's where we're going to fill these in. So again, we're going to start with the 4 quadrant angles that we know, right? So this one's 0 degrees, the top is 90 degrees, the left is 180 degrees, the bottom is 270 degrees, and then we come back around, and on the bottom is that 360. Now the pattern for the degrees is 30, 15, 15, 30. So from the first one, I add 30. 0 plus 30 is 30. Then I add 15, that's 45. Then I add 15, that's 60. then I add 30, and I get to the 90. So if you fill in your 4 quadrants, which is what I would recommend, the 4 corners, then those are like your checkpoints as you go around. But the pattern is 30, 15, 15, 30. And then you repeat it again. So from 90, I add 30, I get 120. I add 15, I get 135. I add 15, I get 150. I add 30, and I'm at the 190. I do it again. 180 plus 30, 210, plus 15, 225, plus 15, 240, plus 30, 270. And one last time, add 30, 300, add 15, 315, add 15, 330, add 30, and you're at 360. So 30, 15, 15, 30. And if you look at the gaps, like the gap from on the 30s are bigger than the gaps on the 15. They're actually like relative size.
If you want to check, can't you just subtract 360? Like if you want to do like the 4th quadrant, can't you just subtract like 360?
You would subtract 30 and then 45 and then 60. Yep.
What's the one after 90?
Sorry?
What's the one after 90?
120. Okay, now I'm going to do the radians. So 0 degrees is 0 radians. 90 degrees is pi over 2. I'm going to actually use that line as my division bar. You could do whatever you want there. 180 is pi. 270 is 1.5 pi or 3 pi over 2. And 360 is 2 pi. So those are your 4 quadrant ones. 0 at the top, pi over 2, on the left pi, on the bottom 3 pi over 2, all the way back around 2 pi. Now all the angles closest to your x-axis are over 6s. So I'm going to fill them in as pi over 6 first. Pi over 6, pi over 6, pi over 6, pi over 6. All the ones closest to the x-axis are over 6. That would be your 30 degrees. So if I did 180 times pi over 6, I would end up with 30 degrees. So if you're unsure, you can check any of them. All the ones closest to the y-axis are over 3. So pi over 3, pi over 3, pi over 3, pi over 3. Again, first quadrant, that would be your 60-degree angle. And then the ones in betweens are over 4s. Pi over 4, pi over 4, pi over 4, pi over 4. In the first quadrant, we leave those angles as they are. Pi over 6 is 30 degrees. Pi over 4 is 45 degrees. Pi over 3 is 60 degrees. In the second quadrant, the numerator is 1 less than the denominator. So 1 less. So it would be 2 pi over 3, 3 pi over 4, and 5 pi over 6. Everything in the second quadrant, the numerator is 1 less than the denominator. Because it's less than 1, because that would be what pi is. Bigger than a half, but less than 1. Everything in the third quadrant is 1 more. So it's 7 pi over 6, 5 pi over 4, and 4 pi over 3, because we're now bigger than 1, but less than 1.5. And in the fourth quadrant, it's either 1 less than double, or just memorize 5, 7, 11. 1 less than double, because double would make it 2 pi, right? And this is less than 2 pi. So 1 less than double. Still with me. So that's 2/3 the way. Now we got to fill in all the coordinate points. So fill in the ones you know. The one on the right is 1, 0. The one at the top is 0, 1. The one on the left, -1, 0. The one on the bottom, 0, -1. So every over 6, which is the first one we're going to pull in or plug in, is √3/2 and 1/2. The signs are going to change. Positive, negative are going to change. But the coordinate points are all that. Oh, that's really hard to read. Sorry. All the over 6s are √3/2 and 1/2. So then I fill in all the over 6s. √3/2 and 1/2. √3/2 and 1/2. √3/2 and 1/2. √3/2 and 1/2. All the over 3s are the reverse of that. 1/2 and √3/2. And all the over 4s are √2/2 and √2/2. So this would be based on a 45, 45, 90 triangle in which the legs would be the same. That's why these are both the same. √2/2 for both. Almost done. We just got to do the signs. So in my first quadrant, what's true about both the X and the Y? They're positive, so they are going to stay positive. In the second quadrant, what's positive, what's negative? The X is negative, so all these X's are going to get a negative. The Y would be positive. In the third quadrant, what's true about the signs? They're both negative, so I get a negative on each of these. And in the fourth quadrant? Good. X is positive, Y is negative. So based on your all students take calculus, think about what the signs are on your trig functions. That's what's in the corners there. So where it says positive, negative in each corner, I want you to fill out which trig functions are which in each quadrant. So what's true about first quadrant? All of them. So I'm going to write it out this time, but you could literally write the word all. Sine, cosine, tangent, cosecant, secant, and cotangent are all positive. Again, you could write the word all there. In the second quadrant, the S stands for sine, right? Which is the Y. The sine is positive, which means its reciprocal function cosecant is positive. And then all the others are negative. Cosine, secant, tangent, cotangent. You could, no, you're going to write the other 4. Yeah. In the third quadrant, the tangent is positive, which means cotangent's also positive, and all the others are negative. Sine, cosecant, cosine, secant. And in the last quadrant, your cosine is positive, which means secant is positive. All the others are negative. Sine, cosecant, tangent, cotangent. So that is what you will do for your unit circle quiz. You'll fill it in. We'll practice it again tomorrow, but you'll fill it in. The other trick I'll teach you is the tangents, and this is just to make your life easier. This won't necessarily go on the quiz, but when you apply it, I promise you it makes life easier. The tangents for each of these, if it's over 6, it's root 3 over 3. So you don't have to do y over x every time. If it's over 4, it's 1, and if it's over 3, it's root 3. The way I remember it is that over 6, like 6 takes 2 3s. So I have a root 3 in the top and then the 3 in the bottom. Whereas the over 3 only takes 1 3, so you only have 1 root 3. So if you can memorize those, I promise you it will help you. If you can memorize those, it will make life easier. Then you won't have to do y over x every time. It says find the trig function, okay? So we start with, obviously, the benefit of having your unit circle is that some of these are going to be, all of the ones on this slide, -1, are going to be on your unit circle. Eventually, we're going to do coterminals, and I'm going to teach you how to do those. But for now, these are all in your unit circle. So if you look at your unit circle, for sine of 3 pi over 2, I'm going to go to 3 pi over 2, which is at the bottom of my unit circle. And for sine, which coordinate am I looking at? Y, which in this case would be -1. Then I go cosine 3 pi over 2. Same angle, but this time I want which coordinate? X, which is 0. Then I go tangent 3 pi over 2. So what happens when I put -1 over 0? It's undefined. Tangent is undefined at the top and the bottom. It's 0 on the right and the left. If you want to learn that, you can learn that too. Then I go cosine 7 pi over 4. So I'm going to go to my unit circle. I'm going to locate 7 pi over 4, which is down here in my 4th quadrant. And I want the cosine there, which is which coordinate point? X, which is positive root 2 over 2. Sine 7 pi over 4, same angle, but this time I want the y, which is negative root 2 over 2. Tangent -5 pi over 3. How do I find -5 pi over 3? I go the opposite direction, or what's the other trick with negatives? You can add 2 pi to find a coterminal. You can do that. You graph as though it's positive, fold it in half. So because 5 pi over 3 is on my unit circle, I think that's the easiest way to do it. I would find 5 pi over 3, which is here, fold it in half, and that overlaps with the one at the top. That's -5 pi over 3. So I'm really looking at pi over 3. If I had taken -pi over 3 and added 2 pi to get the coterminal, it would be pi over 3. So either of the ways that you do that, you'll still get the same answer. So now I'm looking at that angle, and I want the tangent there, which we said what's true about all the over 3's? It's just root 3. This is in the first quadrant, so it's positive. Yep. Yep, if you do y over x, it will give you root 3. Yep.
Wait, how do you know which way to flip it?
You fold it in half like a hamburger.
So on the x.
Yep.
So everything over or under root 3 is like gone.
What do you mean?
Like when you, like every time something is over, is like under square root of 3, it's like just square root of 3. Or just when you flip it.
You mean because the bottom is 3?
No, like for this one, it was 2. It was.
So if I didn't remember that over 3's of tangents are root 3's, I would do root 3 over 2 over 1/2 because it's y over x. And then I would flip it, and the 2's cancel. So that's where those come from. It's just another thing to help. If you can memorize the tangents, it saves you that step every time. Yeah.
How do you know about like the sign of it?
It depends on the location. You mean
For first quadrant, it's always positive.
Everything's
Whereas
positive.
It was like in the second quadrant.
then that's your all students say calculus. So if it's in the second quadrant, sine is positive and cosecant's positive and everything else is negative.
So it'd be negative radical 3.
Yep. If it was tangent of 2 pi over 3, it would be negative root 3.
Okay.
Yep.
Is that for all of them?
Yep. So the other way, like obviously with that unit circle, we can locate it and we can look at it. The other thing you can know is all your over 4s are going to have the same coordinate point. So I don't even have to look at my unit circle to figure out the value that's there. I know that if it's an over 4, it's root 2 over 2 and root 2 over 2. And so my answers there are root 2 over 2. The only reason I need to locate it on the circle is to figure out if it's positive or negative. So just knowing your over 3s, your over 4s, and your over 6s gets you all the values. All you have to do is figure out if it's positive or negative based on the location on your circle. So that's why you need to know what quadrant it's in.
Can you explain how to find this negative and positive again?
Yeah, so like if for these, because they were all unit circle based, you literally just locate them on the unit circle. All students can take calculus. So if it's in the first quadrant, everything's positive. Second quadrant, sine, which is the y, is positive, which means cosecant, because its reciprocal function takes the same, right, is positive. Everything else is negative. If it's in the third quadrant, correct, and everything else is negative. And in the fourth quadrant, cosine is positive, and secant is positive, but everything else is negative. Yep. So eventually we will get to the point in which I can give you something like 23 pi over 4. And you would be able to tell me the sine, the cosine, the tangent, the secant, the cosecant, and the cotangent of that. So the way we do it is instead of finding coterminals, which you totally could, you could subtract 2 pi until you get something that's on your unit circle. Or you convert this into a mixed number. So if I convert that, 23 over 4, into a mixed number, what is it? 5 3/4 pi. 5, I'll show you the long way around first, and I'm going to teach you a trick. But 5, this would be 1 pi, this would be 2 pi, this would be 3 pi, this would be 4 pi, this would be 5 pi. And then 3/4, this is the halfway mark. So if it's less than a half, it's in this quadrant. If it's bigger than a half, which 3/4 is, it's in that fourth quadrant. So that angle is coterminal to 7 pi over 4. Before I even locate it, I know it's an over 4, and my coordinate point is root 2 over 2 and root 2 over 2, and the tangent is 1. Just because I know it's over 4. Then, to know if it's positive or negative, I'd have to locate it. So 5 pi, or 5 3/4 pi is in the fourth quadrant, which means my cosine is positive, my secant is positive, all others are negative. So we will build into that, but the trick is that you want to put it into a mixed number. The odd whole numbers are on the left where 1 pi is. The even whole numbers are on the right where 2 pi is. So if I had something like 15 3/4 pi, I wouldn't want to have to go around my circle that many times. I would jump to the left because it's odd, and then I would figure out, is it less than a half? If it is, it's in that first quadrant after that one. If it's bigger than a half, it goes into the next one. So for right now, all of these are on my unit circle. You just have to know the unit circle, then locate the angle, know if you're grabbing the x, the y, or the y over x. Eventually, we will get to those. Okay, the other thing in your homework is this, which you already know how to do, okay? It's just weird because it mixes in with the unit circle. So in this assignment, and this is one of the ones that you did on the practice for the extra test, okay? It's going to give you the coordinate, right? So like negative root 3 and 1 means I move back negative root 3, I move up 1, and then I would use my Pythagorean theorem. R squared is 4, R equals the square root of 2. I'm sorry, square root of 4, which is 2. And then you would fill in your sine, cosine, tangent the way we're used to, okay? So the homework is a blend of the new stuff using the unit circle and then also this kind of stuff that you've already done. So the difference is, again, is it special angle or is it giving you a triangle to set up, use the Pythagorean theorem, do Sokochawa, okay? So just realize those are blended in together. Calculator work, because this is easy. You also know how to do this. The only difference this time is these answers are going to be radians. So it's going to say use the calculator to find the trig function and round to 4 decimal places. And now my calculator needs to be in radians. Notice none of these have degree symbols on them. That's how you know the difference. So to switch from radians, you're going to have to go to mode, and you're going to go down to where it says degree in radians, and you're going to switch it to radians. So you guys go to setup, right? And that's it. You just plug them in. Make sure you're in radians, and then I would do cosine 1.85. And this is going to give me negative 0.27, we're rounding to 4 decimal places, 56. And then I do cosine 0.5149, and I get 0. God bless you, 8703. Cotangent is going to be 1 over the tangent of 1.3209, 0.2552. Secant is going to be 1 over cosine, negative 2.9234, negative 1.0242, nope, 3. Back to just regular sine, 0.8203, 0.7313, nope, 14. Cosine, negative 5.2825, and I get 0.5397. And tangent, 6.4752, 0.1944. So those are your straight up, just plug them in, but you got to make sure you're in radians. Those should be easier questions, okay? And the way, like, if this did get mixed in with your degrees, the way you would know what mode you need to be is you would look for, is there a degree symbol? Is there a degree symbol? No, then it's in radians, okay? Because sometimes these will have pi and sometimes they don't. Like, none of these have pi.
So does it mean you put less pretty much?
Probably. It'll probably be just like the last one. Only you won't get a retake. Yeah, I'm pretty sure.